Hey guys, this is the first two flaps of the Unit 6 Complex Numbers Foldable. Just so you know, this is our actual unit number 8. We had to change numbers for the district, so just so you know, so if you would feel the need to change this to an 8, go for it, up to you. Okay, so if you guys would go to the next flap, if you need to stop and rewind and replay, go ahead. I'll also make sure this is on my website so that you can go back and rewatch it if you need. Now this unit on complex numbers starts out by having to talk about what an imaginary number is. And for a long time we've talked about how we can't take the square root of a negative number. Well, we actually can. The square root of -1 is defined to be the lowercase I. Okay, so if you have the square root of a negative a, then that negative can come out as an I, and then the square root of a stays put. Okay, one thing that's important for you to note is that I squared is -1, so please be sure to replace anytime that you see I squared equal, or that you see I squared in your problem, make sure that you replace that with a -1. So our first section here, we want to write the following using the imaginary number I. So we have two things we have to take care of. First off, notice we have the negative inside. Because that negative on the inside is defined to be the I, we can pull that I out front. Okay, so here's the I, and then we have the square root of 5. Now the last thing you need to check for is to see if the square root right here, if it's a perfect square and can be reduced. Because if it can, then you need to change it to its number. So pull the I out, and then simplify the root if you need. So as we look at question number 2, we have the negative on the inside, which becomes an I, but then we have the square root of 25. Now the square root of 25 is actually, 25 is a perfect square. So the square root of 25 would be 5. So this would give us 5i for our final answer. So if you notice, it is okay to have square roots, and it is okay to have whole numbers. Just depends on your, just depends on the problem and what is expected of you. Now the second section we're going to talk about simplifies expressions. So if you notice, these have I in them to begin with, and they come with the little squared. So we have to figure out how to handle that. Notice the difference in questions 3 and 4. Question 3, the only thing being squared is the I. In question 4, both the 3 and the I are being squared. So with this one, if we remember from the beginning, the I squared is defined to be -1. So we're going to replace that I squared with -1. So that's what this ends up looking like. 3 times -1, which is -3. Basically, when I squared is stuck at the end of a number, its sign will switch. Now the difference with question number 4 is because both of these are inside those parentheses being squared, we need to square the two numbers separately. So we'll be squaring the I, and we'll be squaring the 3 separately. So 3 squared is 9, I squared is -1, and 9 times -1 is -9. Again, that I squared will change the sign of that number. In question number 5, again, 2 parts, both inside of the square. So we must square the I. We must also then square the square root of 7. Now we talked about in our inverses unit how a square and a square root undo each other. They are inverses. So the square of the square root of 7 really is just 7. Remember also I squared is that -1, and -1 times 7 is your -7. So the idea with this is to make sure that you are in fact squaring numbers if appropriate, and that you are replacing I squared with -1. So now that we've talked about imaginary numbers, we're going to talk about what a complex number is. Now, a complex number has two parts to it. It will have a real part, which is the whole number, and it will have then the imaginary number, which will have an I attached. So a complex number is a real part and an imaginary part. One thing that you will need to deal with is what's called a conjugate. Now, a conjugate basically takes the sign of your complex number, switches it, and then you are done. You have your conjugate. The A and the BI do not change. The only thing that changes for the conjugate is the sign in between them. So if you are to do the quadratic formula, for instance, the imaginary roots, if you were to have a square root of a negative inside that quadratic formula, those are considered conjugate pairs. One is the positive, one is the negative. So when we go to write the conjugate of each of these complex numbers, the only thing that changes is that sign right in here. So we're going to keep the -3 and the 5i, but it will be a negative in between them. -3 minus 5i. So looking at question number 6, again, number 7, that negative will be the only thing that changes. So we have a 9, and then a plus, and an I. The 9 and the I stay put. So question number 8, again, the negative is the only thing that changes. So the 6 stays the same, the 5i stays the same, becomes a plus instead. So whatever sign is there in the original, change that sign, and that will be the sign in your conjugate. So this first page dealt just with imaginary and complex numbers. So make sure you take the I out if you are writing it using the imaginary number. Be sure to replace -1 with I squared with -1 when simplifying. And for the conjugate, change the sign in between them. The second part of what we are doing today involves adding and subtracting those complex numbers. Now, these work very similarly to the way that algebraic expressions work. You will be adding the real parts together, and you will be adding the imaginary parts together. So in this first example, this 3 and this 2 are your real parts, and then the I and the 3i are the imaginary parts. So you have to combine them in their combine the two correct parts together, just like combining like terms. So 3 plus 2 gives you 5, and then I plus 3i gives you 4i. So 5 plus 4i is this operation. Now you must be careful when subtracting. When you subtract, you will have to distribute your negative as you go, so be careful. So when we look at this one, if you notice, the only real part, the only one that doesn't have an I on it, is this -4. And it's a plus a -4, so we're going to leave it a -4. Then you have a 2i minus 2i. Those two will cancel each other out. So the imaginary part is gone. So you are then left with -4. This is simply combining like terms. Alright, so when we look at this one, what might be helpful, because of this little negative right here, it might be helpful to rewrite these and distribute this negative as you go. So this would be 3 minus a -2 is a +2. The minus or negative times a positive 3i is a -3i. And then this plus means that those parentheses aren't necessary, so you can copy that over as well. So now when we combine like terms, all of the numbers without i's attached to them, 3 plus 2 is 5, minus 5 is 0, so the real part goes away. And we have a -3i plus 1i, which gives you a -2i. And then the last one we're going to do Again, it might be helpful to go ahead and get rid of your negatives, or get rid of your parentheses. So we have 8 minus I, and then plus 5 plus 13I. Now remember, we talked about this I squared. That I squared, if you remember, needs to be replaced with a -1. So this last term is -2 times -1, which is a +2. We talked about that I squared makes the sign change. Okay. So when we combine like terms, we have an 8, a 5, and a 2 with no letter. 8 plus 5 is 13, plus 2 is 15. Okay, then we have a -I and a +13I, which together gives you a +12I. So when adding and subtracting, all you need to do is to combine like terms.